Okay, number 6. So this problem this was the most missed problem from last year's quiz. I can guarantee that you're going to see something like this on your quiz. So I'm glad that you're watching the video. So here we have sine of x plus pi over 2 is the first thing we need to deal with. And remember, this is not, the distributive property does not work on a problem like this. We have an identity for sine of alpha plus beta. And here, x would be our a or our alpha, and pi over 2 would be our beta. So you want to go to your little equation sheet and find the identity that goes with that, and then use that to expand. So what the identity that goes with that is sine of a times cosine of b plus cosine of a times sine of b. So writing that out using x and pi over 2 would be sine of x times cosine of pi over 2 plus cosine of x, technical difficulties. Okay, cosine of x times sine of pi over 2. So that is that first portion expanded, that first term expanded. Now we're going to expand our second term here. The second term is sine of x minus 3 pi over 2. So the difference identity there would be sine of x cosine of 3 pi over 2. And then we have minus cosine of x sine of 3 pi over 2. And we have this all equal in this problem to 1. The next thing I'm going to do is substitute in for the values that I can. So I can't substitute in for x, but I can substitute in for cosine of pi over 2 and sine of pi over 2. So let's do that first. So I have sine of x times cosine of pi over 2. I know cosine of pi over 2 is 0. So I have sine of x times 0 plus. And then I have cosine of x times sine of pi over 2. Well, cosine of x is just going to come down, but sine of pi over 2 is positive 1. So I have cosine of x times 1. All right, moving on. Sine of x times cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. So I have sine of x times 0 minus cosine of x times sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. So I have cosine of x times negative 1. And it's all still equal to 1. All right, let's look at what we have here. We have some things we can get rid of now. We can cancel, well, sine of x times 0 is 0. And so is this one. Sine of x times 0 is 0. I have cosine of x times 1 is cosine of x. I have negative cosine times negative 1. That's positive cosine. So I have cosine plus cosine, still equal to 1. Cosine plus cosine is 2 cosine. And so I have cosine of x equals 1/2. Now, where does that happen? Well, cosine is 1/2 on our unit circle, between 0 and 2 pi, at pi over 3 and at 5 pi over 3. Now, let's decide if we need 2 pi k or pi k. So I'm going to draw my little diagram. Pi over 3 lives in the first quadrant. Again, that's where we're looking for positive 1/2, so all students take calculus. This tells where our trig functions are positive. So cosine's positive in the first quadrant and the fourth quadrant. That's where 5 pi over 3 comes from. So 5 pi over 3 is down here. Since those are not pi apart, they don't make a straight line. We're going to do plus 2 pi k for both of them. That gets us every rotation. So every time I hit pi over 3, I get a solution. Same thing with 5 pi over 3. Every time I rotate it from there, I get a solution. Again, this problem is not difficult. You just have to remember to use the sum and difference identity instead of the distributive property. The distributive property does not hold with sine and cosine when you're dealing with the angle values. You can't just distribute sine in or distribute cosine in. All right, that's number 6.